Alright, welcome to our engineering control final project. Okay, I will explain about this. This is our water debit manager. So the component consists of simple parts. It's about PVC, and then there is a water sensor, water flow sensor. I'm sorry. There is a LCD, and we have an Arduino in the downside, of course. And finally we have a PVC joint and also servo motors. Okay team, I will explain the working principle. The working principle is so simple, of course. Here in LCD we have next, previous, done, and back. Here I'm going to select the debit. We can set up our debit as high as we want. Okay, right now I will select Q 2.5, and this is KP. This is in KP, or we can say it as proportional gain. We are selecting the KP right here. So I will select in this state is 2 because exactly the lower KP will be make the system unresponsive, of course, and if KP is too high it will vibrate our system. So I just select it as medium. We can try another KP next, but I will select right now is 2. And this is step quantity. Step quantity right here meaning the tolerance, of course, because I will make our system as an feedback P or proportional. So I will select it the minimum, so I will select it 0. So we have done our configuration. So let's get action. Alright team, before we are going to know how our tools is working with actual process, I forget to tell you something. So before we are setting up the debit is 2.5 liter per minute. So defaultly our pin balls will be open like this. Okay, and exactly in water, the real water source, it's fluctuative. I mean, we don't know how much the debit comes from water source. It can be 3, it can be 5, or it can be 1. However, our pin balls will be open and closed, so it maintain our water flow is constant as 2.5 liter per minute. How it works? So the water will flow, go through in to the pipe, into the pin balls, into the default pin balls, and it will becomes to water flow sensor. And after the water flow sensor, we have an output. So the Arduino down here, okay, will be reading how much our output, and it's setting up our tools, exactly our servo motors, to know that this is not 2.5 or this is exactly 2.5. So if the value is not 2.5, for example, it less than 2.5, so we are going to make it more fast into 2.5. How it can be faster, we will more close these pinballs a bit so we can reach the 2.5 liter per minute. If there is too fast, more than 2.5, so the motor servo will open this pinball, so it will be lower the speed into 2.5. So because our output is read to by Arduino and make the output into the input again, so we can call it a feedback P systems. As simple as that. After it, why it's also called a feedback P system? Because we are keep maintaining the 2.5 liter per minute into its actual number, so it's not fluctuative. Okay, the difference about from the on-off system. In on-off system, we are not keep the output constant, or it can call more fluctuative. Yeah, that was exactly the opening and closing process for maintaining the water debit.